So yeah. So this is the question they're asked in 2014. A conducting sphere of radius r is given a charge q. The electric potential and the electric field at the center of the sphere respectively. So this question is most familiar and fundamental. So here there is a sphere. I know if it is a charge conductor, charges will reside only on its surface, and it's a radius. Let's take capital R. The potential at the center is equal to the potential on its surface. That's what it's a q divided by 4 pi epsilon 0 into r. Whereas the electric field at its center, the electric field at the center of the sphere is 0. So E is 0 and the potential will be q divided by 4 pi epsilon 0. So therefore here they are asked in order: first electric potential and electric field. Let's set the option. So electric potential first, that should be q divided by 4 pi epsilon 0 r. So q divided by 4 pi epsilon 0 r, and the electric field intensity is 0. Therefore the best option or right option is second one. And let's see the next question, and it's familiar and repeated question many more times. So in the region, the potential represented by V is equal to 6x minus 8xy minus 8y plus 6yz. The electric force is experienced by the charge of 2 coulomb situated at 1,1,1 is okay. So in past questions there asked only electric field. Here they are asked force which is experiences by the 2 coulomb when it is in the given electric field. So therefore we know how to find out the electric field if they have given electric potential. Already we have done this kind of questions. This is what E is equal to EX I cap plus EY J cap and EZ K cap. Now you know what is the relation between electric field intensity and electric potential, that is minus dV by dx. It means, so if you want to get Ex, we need to differentiate the above V with respect to S. If you want to get Ey value, we need to differentiate V with respect to y. To get Ez, we need to differentiate this V with respect to 1. So let's differentiate this. In order to get Ex, that's what minus of dV by dx. When you differentiate this dV by dx, so differentiation of x with respect to x, that will be 1. Therefore 6 only, minus differentiation of x 1 and remaining 8y, and there is any x factor, therefore remaining 6 minus 8y I cap plus here minus, that's what minus dV by dy. We need to differentiate this v with respect to y. We need not to take this factor, only this factor, minus of differentiation of this with respect to y. So y is not there, it will be 0. Then so differentiation of y, it will be 1. Then remaining minus 8x, and differentiation of y 1 remaining minus 8, and differentiation of y1 and plus 6z j cap. So then to get Ez, okay, so Ez k cap, we need to differentiate this with respect to z. So this factor will be 0, this factor will be 0, this factor will be 0, we need to differentiate this only. Differentiation of v with respect to z means differentiation of z will be 1, remaining it will be 6 by k cap. And when you multiply this minus sign, minus into plus minus, so minus into minus plus 8y I cap. Similarly here also 8x plus 8 minus 6z j cap, and my plus into minus minus 6y k cap. And know the coordinates. It's x comma y comma z. When you put x y z values here, we'll get e value. E is equal to when you put our y value 1, so minus 6 plus 8, it will be 2 I cap plus, so when you put x value 1, 8 plus 8 16. When you put z value 1, 6, so 8 plus 8 16 minus 6, it will be 10 j cap. Then here minus is there, minus y value 1, so then it will be 6 k cap. To get e value, magnitude of e, so we'll go for of 2 square plus 10 square plus 6 square. Total what will get? Square root of 4 plus 100 plus 36. So it means, so e is equal to, it is 136, 4 totally, root of 140. So root of 140 we can write like this. That's what, square root of 4 times of 35. 4 times of 35. 35 into 4, 140. So we simplify like this only to get a required answer. That's it. So square root of 4, it's a 2 root 35. This is the electric field. So the electric field E will be, it is 2 root 35. But they're asked to find the electric force experienced by the charge 2 coulomb. Therefore, so force F will be EQ. So therefore, F is equal to E value, so 2 root 35 into 2. So therefore, F is equal to 2 into 2, 4. It will be 4 root of 35. So 4 root of 35, the answer. So 4 root of 35 Newton is the correct answer. Okay, next I will see the next question. There is a question in 2015. The electric field in a region is acting radially outward is given by E is equal to capital A into small r. A charge contained in a sphere of radius small a centered at the origin of the field will be given by. So see what they have given here. So one charge is placed at its centered, and the fields are acting radially outward, and that's radius is also r, and charge is contained in the sphere of radius. that is A. Therefore, when I take this sphere A, then that is equal to R. When A will becomes R, then the expression for electric field E is equal to known, and it's a simple formula. That's what 1 by 4 pi epsilon 0 Q divided by it is so it is A square. Now, so here we know what they have given. E is equal to AR. Since R is equal to small a, therefore E will becomes A into small a. So therefore when you substitute that value here, so A into small a, then that is equal to 1 by 4 pi epsilon 0 Q divided by it is A square. To find the charge, a charge which is so contained in a sphere, so we need to find out a charge. In order to simplify this, let's simplify this. Okay, we'll bring all these factors into left hand side, then only Q is left on the right hand side. That's what 4 pi epsilon 0, 4 pi epsilon 0, then what? So A is there. Okay, A into A square, it will be A cube. So therefore Q is equal to 4 pi epsilon 0 capital A into A cube. So the right answer is 4 pi epsilon 0 capital A small a cube. This is the right answer and simple method. And see in the next year question in 2016, they are asked like this, and most familiar and important also, repeated